Okay, here we go. Microphone looks a bit loud, but maybe it's fine. So yeah, I'm gonna be back to working on Jolt today. I haven't actually worked on Jolt on Jolt and integration in 2 or 3 weeks. So it's gonna be interesting getting back to it. I'm gonna start by checking where I left off. Physics test. Alright, yeah. I was trying to get the compound collider shape to work. And I think it's actually kind of close. Yeah, it's close, but the position of the child colliders are incorrect. So I have to try and fix that. So it's possible that this line of code isn't getting hit, meaning that we can't actually get the translation. So let's do a test. Also, the microphone should be a lot better because I got a new one yesterday. So let's see if this... Yep, it does actually happen. Let's see what the translation is set to. 0.45, which I don't think is correct. Well, I mean, it's mostly correct, but that is relative to this poll, whereas I think Jolt wants it in... I think Jolt wants this in world space. So this should actually be the actor Y plus this. Let's have a look in Jolt rigid body. Yeah, so it would be this. Igorsek, what's up? I'm doing good. Got a new microphone, so hopefully it should sound a lot better. Ralph Yeager with the 100 bits. Awesome, dude. Much appreciated. So yeah, this should basically be this plus this. Transform. Although, couldn't it just be world space transform here? I think it should be. Seeing as Joe wants it in world space, apparently. Actually does it? I don't think it does. Let's give this a try. Yeah, no, it's not world space. What exactly am I working on right now? Just trying to get the Jolt compound collider system to work. Basically what that is we can basically have multiple colliders kind of combined together so that Jolt can handle the collision detection a lot more efficiently. And right now I'm struggling with it because the basically these colliders here should be part of this sort of actor, right? But the thing is, they're not positioned correctly for some reason. And world space doesn't seem to work, and neither does sort of local space. So I'm unsure what's up here. I would have thought local space would work. Where Jolt shapes. But I'm unsure as to why it's not working. Unless we're doing something really dumb. Let's take a look in here. So this is taking the shape. Position of the sub shape, yeah, but in what space? Local or world space? Why is it half size? It's very common for you to do that in pretty much all physics systems because I actually don't know the exact reason, but I think it has to do with the fact that if you have a half size, it's much easier to generate, I don't know, access line bounding boxes or some shit like that. It's the same thing in physics. You have half size. Prophet2. Sorry for mispronouncing that. Thank you so much for following. Tell you what, if we go into physics shapes, yeah, you tend to use half size everywhere. Tell you what, let's actually check in, because it's possible that the collider size is incorrect, and that's what's causing the problems. So if we go into, come on, thank you, physics shapes, here. Okay, so it's, yeah, so it is that. So that's correct then. So for some reason, this translation is wrong. So what happens if I just do 0? because this will kind of let me figure out which kind of transformation space the translation is supposed to be in. Because if it's close to the floor, then it should be in world space. If it's close to the center of the pole, then it is in local space. Right, so basically if it's local space, this box should collide around this point. If it's world space, it should be around like the bottom of it. So that definitely looks like it's supposed to be in local space. But that also means that this position does nothing. Because when I provide it with a translation, I think it still collides around the center point of the pole. So well, does it? I mean, it looked close. Yeah, that definitely looks like it's close enough. Which means this one doesn't really do much. So let's maybe dig into the code a bit. So it does this and does subshapes push back. And how do we then create the actual shape? We do this using a static compound shape. Oh, hang on. Could it be this? What is Jolt in Hazel? So Jolt is basically a library that adds 3D physics. So it's similar to PhysX, but it's written in modern C++. And if we take a look at Jolt physics, it's also the library, the physics library that they used in Horizon Forbidden West. And if you don't know what Hazel is, it's a game engine that I'm working on. And I want Jolt physics. So, okay. Here's an idea. Instead of doing this, let's go into box shape, into this one, and create a rotated translated shape. Which takes in the position, the rotation, and the shape settings, or the shape. We can just give it the settings. So and it takes it as a pointer. Let's just use get pointer. Then we do Will you support multiple physics? Yes. The plan is to support both Jolt and physics. Assuming that they prove, like, if it's worth it, right? So if it turns out that Jolt is actually just a pile of garbage and it runs like trash, then obviously we won't actually end up supporting it, but I don't think that will be the case. I think we will end up supporting both. Shape settings, result. So let's try this instead. That's interesting. That seemed to do literally nothing. Well, I mean, I do suppose we're still like doing this. Which could cause problems, I guess. And yeah, like the thing is, Jolt doesn't even have any real documentation. Like it has some documentation, but not a lot. And so I'm kind of left to just experiment and see what works. Yeah, this doesn't seem to be working at all. Let's bring that way up. Yeah, it doesn't seem to be doing anything. What if I do this? Yeah, no. Does literally nothing. Why? Maybe the scale is wrong, maybe it's something like that. Although I don't think it is. Okay, let's maybe try accounting for rotation here as well. Yeah, integrating something without documentation, it's painful. Like, they do have some samples, but the samples are very basic. Like, to the point where they're barely even usable, I think. Okay, so rotation isn't set. And also, let's just go ahead and give this box shape translation. So why isn't rotation set? We do set it. That doesn't make any sense. Oh, forgot it's some colon. Because I think, yeah, these do have rotations. And now it just flat out doesn't work. Okay, tell you what, let's copy that, paste it here. So in theory, if this is world space, then the actual collider for this one should be exactly here, right? So if I move this up to say there, wait, simulate, we get a crash. Okay. Interesting. So we failed to create a shape, I guess. Failed to create box shape, invalid convex radius. What? How? Maybe this shouldn't be world transform scale. It's possible it should be local transform. But why did that crash happen? That doesn't make any sense. It was just working with the exact same code. Maybe it failed to create this one. That's very possible, actually. Let's maybe scale it up a bit. Set it to have a 1 by 1 by 1 scale. Move it up. Ah, hang on. No? Some math magic, pretty much. Maybe it doesn't like the fact that the C scale is so low. Let's try that. Oh, I was apparently in simulation mode. Try 0.1. No. What is this weirdness? Well, I mean, this is technically wrong. Why am I doing this? Could just be that. I may have to look at some of their samples and see if I can figure something out. Because the weird thing is, right, if I now go ahead and remove the rotation, I think it works. Sort of. So remove the rotation and... No, it doesn't work at all. What? Yeah, that's not weird at all. And I mean, the colliders are being calculated correctly. Oh, hang on. I forgot to undo. No, I didn't. What? Okay. Let's maybe try this in debug mode. And let's also take a look at there. Where is it? Samples. Nope, that's not it. Shapes. Static compound shape test. Let's take a look at that. So they create that, they add a bunch of shapes like this. I mean, this is pretty much exactly what we're doing. Right, because we add the shapes. Because even if it's at 0, this is so weird. Maybe Jolt expects a different coordinate system. This is where it would be really useful to have an actual debugger that you can attach to and just see it visually. Okay. So now it is here, right? Now the question is it oriented also why I'm in debug mode? That's why it's so slow. Okay. So what if I drag this over here? Oh, great. Okay, so it's oriented like this, which is correct. That means the scale is working. But the translation isn't quite working, right? But that's fine. So, first of all, let's switch this over to release mode. If I give it a vector now, and we give it 1 in the y-axis, right? So 1 unit up, if I understand it correctly. Let's give that a go and see where it is. Right, so I'd expect it to be there. So 1 unit up. That is not where I expected it to be. So I suspect my units are incorrect. Somehow. Okay, so we now know the units are wrong, somehow. So what does this represent then? Does it have to be multiplied by the size of the parent? Let's take a look at what the scale of the pole is. So the scale of this is 5. So if I give this 5, then maybe it should be at the very top of the pole. That's very possible. That to me looks like it's twice as high as the pole. So it needs to be... Okay, I think I'm starting to understand it. It's based on the half extent of the kind of parent collider. Yeah. So if I set this to 2.5, it should be at the top. Because the half extent is 2.5 for that pole, because it's half the scale. So this should be right there. Yeah, that's it. This has to be kind of... Okay. So we get the half extent of the... Well, how do we even do that? Yeah, no, we get the half extent of the kind of actual actor, right? So we get the half extent of the actor that has the compound collider on it. And then we multiply the y value of this. No. Because this is 0.5 up. Almost. That means we need it to be multiplied by the full scale of the... Oh, yeah. Because 1 would be that. 0 is in the middle. Negative 0.5 is at the floor. Yeah. I got it. Now I understand it. Okay. Because that's very interesting. That means we need the translation of this multiplied by the full extent. Right, so multiplied by the scale of the rigid body. So we effectively need that as an offset almost. Right, so... Question is, could I have a... Also, I'm sorry if you just heard my cat. Okay. So, in here, where we do this, we need it to be... So the scale of... World scale or local scale? Probably world scale, I think. Let's see now. Rigid body transform. Yep, world space transform. For M entity. So this needs to be that multiplied by rigid body transform dot scale. Effectively. So bring in the translation. In theory, it should be in the right place now. So if I do here, it doesn't collide with anything. Over here, well, that didn't look quite correct. No. So it's like up here. So maybe it shouldn't be world transform. Well, I mean, in this case, it shouldn't actually matter. Okay. So it's not quite correct yet. Let's go debug mode so I can check the values here. This is actually kind of annoying to have to deal with. Okay, so translation 2.29, which is correct. And rotation is weird. But I think maybe that's correct. So maybe now it's just the rotation's weird. Because that could be what's happening here as well. Let's try something. Well, it does successfully land on that. Hey! It was the rotation causing problems. It's in the correct place. Let's verify the other ones as well. Yes! Oh, that's so awesome. Why would they do that though? Why would they have it be based on that? Well, I mean, I guess it makes sense because in that sense it's an offset in local space from the origin as opposed to like an actual position. Oh, that's so awesome. Finally. Okay. Now, how do I standardize that? Because that means do we have a way of figuring that out without actually having each shape have these values? Well, because we know our entity. So we can actually get our own transform like this. And we can get the entity of this shape as well. So yeah, we can do this. We basically have to do M entity, presumably in world space, I imagine. Well, we'd have to get the scene. Get scene, entity, get scene UID. Start doing that. Then we do transform component. Call it rigid body transform. Yeah, world space transform for M entity. Like that. We then get the transform component shape transform, which is going to be shape M entity, which I don't think I have access to. Yeah, no, I don't. We're gonna need to make a getter for that. We grab the shape transform. And then we have, so it's translation multiplied by scale. All right, so this Jolt utils. Also, I'm just gonna move my microphone real quick. Okay. Hopefully that didn't cause your ears to bleed too much. So it's the shape transform, translation multiplied by the rigid body transform scale. And this was just shape transform get rotation, I think. Yeah. Which means we don't need this. And we don't need a special constructor for the actual shape either. Which makes this a lot simpler. So get rid of that one. And completely get rid of that. I like that. That is so nice. Okay. And they should now work. I'm so happy that we have got this working. Yep, still works. Good. Awesome. Finally. I'm immediately going to push that. Compound shape now works. Let's push that. And I'm also gonna fix up the mutable one. Should just be able to do a copy paste. Cool. Let's maybe get the sphere colliders to work now. That we have these guys mostly working. So we'll need a sphere shape. Sphere entity. Radius. The radius. Let's just copy this. For now, it won't actually return anything. And this won't do anything. Create the implementation for it. We can get rid of these. We can specifically have a sphere shape, I think. Same thing here, have it be a box shape. which requires the radius. So how do we do this for physics? We used to get the largest component and use that as the radius. And then multiply that by the component radius. So largest component multiplied by sphere collider component radius, and that's it. So in theory, that should be it for sphere colliders. I really need to get a boom arm that I can have the microphone in a better place so I don't hit it. Okay, so that's all good here. And yeah, I think that should just work. Like magic. Cannot instantiate abstract class. What? What's up with that? Because I'm not overriding the destroy function. And I'm also not overriding this. Okay. Now it should be fine. Okay, let's check if that worked. Hopefully it did. If it did, then this sphere collider should just actually work now. And it seems to work. Let's have it actually hit the edge of this so it gets a bit of roll going. Yeah. Sphere colliders, they work. Cool. So The question is, should I finish implementing the other kind of basic shapes? Or should I move on to something that's a bit more interesting? Because we just have the capsule collider left. So I think it's worth just finishing that up and leaving mesh colliders for another day. Pinspin, what's up, man? Did you hear about the ore machinery thing? Yeah, I did. It's kind of sad that they decided to shut down and force everyone to destroy their copies of the engine. But at least they gave refunds. I actually saw a tweet in response to... Actually, let me see if I can find it. I think it was in response to Games from Scratch, who commented on that. Let's see here. Yeah, it was in response to Game from Scratch, who made a tweet about it. There was a guy who pinged Jan and was like, please promise to never do this with Hazel. Which I thought was kind of funny. Just a wild Hazel user. So, capsule very similar to sphere. Radius and height. Let's just do... Oh, I don't think it's called capsule shape in Jolt, though. No, it is called capsule shape. I just need to include it. Awesome. And I need to remember to override the height related ones. Also, I'm super excited because, well, yeah, I can probably say this. I think it's fine. Basically, we're going to be doing. I don't think it's a secret. We're gonna be doing London Dare again in, is it September? End of September, maybe. I think it is. I'm actually really excited for it. And this time, I'm actually gonna try to do a 24-hour long live stream because I failed to do that last time. Capsule collider. No capsule collider component, thank you. Here it's different because we're only doing a max between X and Z for largest radius. What's up, Emily? Might actually be able to get the Linux up to code before London Dare this time. Well, we'll see. This post was made by the Windows 11 gang. I mean, if you could get it up and running and actually have it be properly stable before bottom there, that would be cool. But I don't know, we'd also have to do quality assurance on it. Which, like, we've already started the QA process in preparation for Bottom there for the dev branch. So, don't think Linux will be meeting the QA requirements for this Bottom there. Yeah, it could stay as a community build thing. Like, I mean, there's nothing preventing us from doing a Linux build of the Bottom there game at some point. So, let's see here. This should be capsule shape. Also, hello, Tony. I think stable and Hazel don't fit too well in one sentence. Yes, it does, because it is a lot more stable. Stable and hazard, however, doesn't fit. Height of cylinder, half height. So that would be height. Is that height or half height? Let's try this. Multiplied by that. And then the radius, which is largest radius. Multiplied by... Well, it's actually that. Windows 11 taskbar on top doesn't really work that well. Yeah. I mean, obviously Windows 11 still has some issues, but... Okay, looks cool. Should probably rename the capsule components height parameter to half height. Right now, I'm just trying to figure out how to write a normal-ass character control in Hazel C#. Yeah, good luck with that. I don't even know that I could do that. Oh, so you want to move it to the top? Well, you can do that, but everything else will still act like it's on the bottom. Really? Wow, that's crappy. Yeah, I definitely agree. Windows 11, like, I love it. I think it's so much better than Windows 10 in most areas. But yeah, it does lack a lot of the stuff that was in Windows 10. Do we have a capsule? We have. Sorry about that. Well, I mean, Windows 11 doesn't get constant updates like Windows 10 does, and it doesn't force you to restart, so I don't know about that, Tony. So this isn't half height. Which is weird. Wonder if C# could do vector swizzling. Yeah, we have that. To some degree at least. Like, I think we do. Well, we have the constructors that let you swizzle a vector. Right? So vector 2 has a constructor that takes in a vector 3 and only uses x and y. We could, of course, do like a vector 2 xy. Like that. Vec3.x, vec3.y. So, I mean, you could use it, you can make it into like a property if you wanted to. It's not super efficient, but I guess you're constructing new objects, but you kind of have to. Okay, so let's go ahead, go in here. Do half height. Yep. Static swizzling as a language feature. Yeah. That's probably useful, but not a thing, I don't think. Yep. Which one's this? Yeah. So. Oh, okay. Yeah, it's the string. Got it. Yeah. Let's run that. Okay, but for real, the funniest thing about Windows 11 is the fact that you have modern Windows, but the content is from the 90s. Yeah. Pretty much. Okay, let's see if there were any build. If there are any build errors after this. Like mouse properties. Yeah. There's definitely some issues like that. Dropping frames. Like, if you make stuff look nice, at least make it consistent. Yeah, I think that's definitely something they should have done. Okay, so it builds good. Let's go into scene serializer. And we'll say, where are we doing deserialization here? Let's have this be 0.5 by default. We really should have defaults for all of these. And we should fix up the old way of writing that as well. Okay. Where am I? So, what we'll actually do here, because we want to be nice, is we'll do if that at height. Otherwise, use half height. And divide it by 2. Specify 1 as the default. Just so we have some amount of backwards compatibility. Okay. Let's run it. I'm actually amazed that my microphone didn't pick up that car going past blasting music. Okay. Load up physics test. Check this. It should now be 0.5 there. Good. And now it's accurate. Yes. Awesome. Capsules work. Okay. We now have that working. So the question is, what's the next step? Because like I could do the mesh colliders, but I don't want to do that yet. Because that is a lot more complicated in Jolt. Well, I mean, in general, it's a lot more complicated, and I don't have the API set up for it. We could set up physics to support sphere colliders and box colliders and capsule colliders. Well, they already support box colliders. Because this would be very simple, I think. Because like most of the code already exists. Yeah, let's just quickly get that set up. Just take in the entity. We'll just have it return nothing for now. Offset isn't a thing yet. Neither is this. Neither is that. Or that. Or that. Or that. Okay. So we need get native shape. And destroy. We also need a material. Wait, what? Oh, I copied that. Destroy. Make these virtual overrides. Same thing for hide. Get rid of these. Override, destroy. Cool. Come on. Okay, no. I'm just gonna get rid of all of this code. Start over from scratch. Set heart size, is that even a thing? Apparently it is. I mean, arguably this should be named get half height in that case, but whatever, don't care. Create. And let's just steal this. Sphere collider. Grab that. which just takes the radius. Natural geometry. Again, this becomes between X and Z. World transform KLY multiplied by component radius. No, component half height. There we go. All done. Going to physics rigid body. Make sure we can support oh, we're not actually dealing with shaped. Well, we sort of are. Through this method. Kinda don't want that. I'm gonna have to redo this API a bit. Because obviously physics in Jolt works very differently. So in Jolt, we need to know the shapes beforehand when we create the actor. Whereas in physics, we don't. Which is why, like, attach shape here doesn't do anything. We could arguably make that do what create shapes for entities doing. But I'm not sure about that. Let's maybe work on something else other than collision shapes. Maybe physics layers could be interesting to work on. Okay, so apparently I need to restart my PC. Why? You having problems? You running Windows 10? Also, is my t-shirt messing up the webcam? It looks really weird. A little. Well, yeah, it's kind of getting bit rated. If having only one SSD showing up is a problem. I mean, your other SSDs may be failing. And Windows is pissed off. Okay, good, that builds. So, how do physics layers work in Jolt? Is the question. Where do we have Jolt scene? And I think it has to do with these boys. The actual broad-faced layer interface. I think I might fold a suit in a few hours and stream some Hazel stuff. For now I gotta go, see all around. Have a good one, Emily. I disconnected them when I installed Windows, just connected them back before you turn this crap on. Awesome. So yeah, we basically have to create a bunch of these broad-faced layers and these guys for each physics layer. which means that each physics layer actually needs to determine if it's... No, because I think we always have to have a broad face layer for each layer. Yeah. Sounds good, Tony. Don't know how much longer I'm going to be streaming. Probably at least an hour, I think. But I do have some other stuff I have to take care of today, so I can't be streaming all day. I'm just really kind of excited to be streaming now that I have an actual decent microphone. But yeah, so we basically have to do this for all of the physics layers. Now, we go into physics layers. Each layer has a layer ID. Which I think is just a sequential value. Okay, fine, whatever. Don't show me where stuff is. Get next layer ID, which just returns, yeah, so it's a sequential thing. Which does mean this is probably gonna be a lot easier than I thought. Because that means we can just resize it to the layer count. Right? So, whoa. So if we include physics layer, get layer count, so we resize to layer count. We do get layers. At layer dot layer ID, which I'm pretty sure, I'm pretty sure that will just be straight up sequential. Is equal to JPH broad face layer, which takes in a number, right? So let's go layer dot layer ID. Yep. Right. And I think this will literally just represent the layer ID. Right? So we don't do a switch on this. we actually need to do physics layer manager, get layer. Which, does it have an implicit conversion? Oh, you can actually override. Oh, it's literally just a 16-bit integer. Okay. So it seems you can also override your, like, the actual object layer filter, which is interesting. Let's do const auto reference layer data. And I believe we just need to compare. How do we actually do this in physics? Simulation filter shader. So obviously we need to check if they're the same. We need to check, does it collide with itself? So if we literally return layer data, well, if they're on the same layer, then we can just return collides with self, I think. Otherwise, we check if they're triggers. I don't know if that's how you're supposed to handle this in Jolt. Because in physics, you just set it here, like to be a trigger. I don't think we do that here. So let's just leave a little to do. Triggers. Otherwise, continuous stuff. Yeah, whatever. Otherwise, we need to check if this one's collides with contains the bit value of this layer. Let's say layer data 1 and layer data 2. Otherwise, we will return layer data 1 collides with and layer data 2 bit value. I'm pretty sure. Right, how do we deal with this? Because if it's non-moving, it can be... okay. Function that determines if two broad-faced layers can collide. Well, isn't that basically the same thing here? Well... I think it might work. Except... no. I'm not sure how to deal with this. To be honest. Because obviously because this assumes that you have moving versus non-moving. The thing is, though, that's not quite how it works in Hazel. Because it's not the layer that determines that, it's the type of the rigid actor. Now, we could obviously make it so that they have basically a object collision layer and a broad face collision layer when using Jolt. That way we could say, you know, static actors are always on the non-moving broad face layer. Which is obviously going to change this a bit. problem is, how do we do that? Because this maps from an object layer to a broad face layer. Yeah. One second, I'm gonna make a phone call. Okay, I'm back. I'm gonna have to step away in like a couple of minutes again because my sister's coming over to borrow some butter, but it's fine. So how am I gonna solve this? Because yes, I could have a broad face layer for every single layer, but yeah, dealing with this is interesting. Because obviously static actors should only ever collide with moving actors. I think for now, what I'm gonna do is literally just do this. Copy paste it. Well, I think I'm gonna have to set up a better structure for this. Because we effectively have to find the layer, the object layer that this broad face layer belongs to in this map or in this vector. Okay, so now I have my drive showing up, but where's my audio? You're struggling. All right, so we can do this. And I mean, I guess because this effectively contains the object layer ID as well. So I can just get the value, right? So I can actually do layer data2. This isn't going to be super optimal. Now this won't quite work, but let's cast it to type. What is type? Uint 8. Let's do that to get the layer. And then we can say if the layer ID is equal to that, we return if it can collide with itself. Otherwise, we return that. For now, I'm gonna come up with a better system for this at some point, because we can definitely make it so it's a bit more optimized. But for now, I'm just gonna settle for this. And in theory, that is all we have to do. Well, no, because we need to tell it. Where is it? Jolt rigid body. Here. I think this represents the actual layer. Yeah, it does. So that is just going to be rigid body component layer layer ID. Okay. I'm gonna have to step away from a moment because my sister's gonna come over now and just grab some butter, but I'll be back in a moment. And I don't have a break screen, so I'm just gonna mute the microphone. There we go. I should probably start muting with my keyboard shortcut so I don't touch the microphone so much. But yeah, so in theory, this should work. In theory. Unless I misunderstood completely how you're supposed to handle layers in Jolt. And I mean, we're technically not handling it correctly because the broad face layers, like, they're not super accurate, I don't think, but let's give it a go. So, I believe, so this one's static and it would be on the default layer. This one is also on the default layer. Right. Okay. Yeah, what now? How? What? Okay, that's interesting. So now I might try. Audio is back. Cool. Wait, what? This gets called before this ever runs? How does that work? What? How the hell does that work? Because... Wait, what? Okay, because we created here, which should call the constructor node. Need to restart. Okay. How can this be called before the constructor has ever been called? That doesn't make any sense. What kind of bullshit is that? Why is it called? Because we create a... It's called from create rigid bodies, which gets called here. At which point this should already have been created. Is it just that my breakpoint isn't being hit for some reason? Is that like optimizing away all of that stuff? That's super bizarre. It's static, so it can't be. Well, actually, hang on. The fact that it's static is a bit of a problem, because this may not have been dealt with by that point. Yeah. Okay. I'm probably gonna end up moving this into its own class at some, or into its own file at some point, so we don't have to deal with forward declaration. But broad base layer interface. For now, I'll just do this. This expects a reference. Let's dereference it. Again, this is not final code. This is gonna change. First of all, so we don't have to forward declare it, and secondly, so we don't have to use a raw pointer. Even though, like, I don't really give a crap about using raw pointers. It's perfectly valid to use them on occasion, but might as well be good about it. Thing is, though, I still don't understand quite why my breakpoint wasn't being hit. Let's check this. Okay, now it works. And yeah, it does seem to be working properly. But let's do a quick test here. So I'm gonna duplicate the cube. I'm going to see, okay, so we only have a default layer at this time. So let's add a layer, call it test. All right, and we'll set this up like that. I'll duplicate this again. And I'll set this one to have the test layer. We'll hit simulate. They do in fact collide. But if I now go and say that you will not be colliding with the default layer, then they don't collide. Awesome. Okay, what if it collides with the default layer but not with itself? And we set this to test as well. Oh yeah, that works. Cool. Obviously not super optimal. This should definitely not live in the scene class. Because I imagine it will get a lot more complex over time, because we do want to handle broad face layers a bit better. So for now, I'm gonna move it into a Jolt. Let's call it Jolt layer interface. And we need to include broad face layer in there. Layer interface. Let's copy this. Okay, so apparently we don't have access to that. Where is it defined though? In broad face layer, which we are including. So what's the damn problem? Must be a class or namespace name. It is. Jolt physics collision broad face layer. That is correct. I mean, we need stuff like vector and stuff like that, but we also need physics layer manager, which I think actually includes vector. Physics layer. Suppose we should include base as well. So we get access to that. But why doesn't this work? When it works in here. That's what I like to call bullshit. I'm literally including the file. Oh wait, no, I know what's up. I know exactly what's up. We need to include basically before we include this stuff, we need to include the where is it? We need to include this to compile it. So what I'm gonna do is just add a CPP file. Jolt layer interface, which will include that and that. And now it works. And it's happy. We could even like implement this in the actual CPP file, which I guess I should. I'm actually gonna copy this entire thing. Just so I have the implementation as a reference. And it doesn't like it. Alright, whatever. I can copy the implementation from elsewhere. Let's do that. This can be in the header. Yeah, that doesn't really matter too much right now. So let's implement these boys. That. And this. Cool. Let's delete this one. Arguably, the layer interface should have these guys as well. And in here, we'll go ahead and include Jolt layer interface. Let's make it a unique pointer. Jolt layer interface. Like so. Which I believe will construct it. Let's rename it to layer interface. Doesn't unique pointer override the dereference operator? Yes, it does. Which means we should be able to just do this. And we can get rid of that. So that's a bit better. I'm actually gonna be heading out in about 15 minutes, so... But I kind of wanna check the state of this and see... I'm gonna have to plan out the whole rigid body interface, or that whole API a bit better, I think, because right now it's not super consistent. Oh, and of course I forgot to save this. You just got here, Marka. God damn. I mean, I'm planning on streaming again tonight, so you can probably stop on by then, unless you're busy. Let's set this to test. Duplicate it. Check. Test doesn't collide with itself, but it collides with default. Hit play, and we get a crash. Woo! So why? It's null. It is. Yes, it is. Because we need to make the unique pointer. It's nice when you're using earbuds and then you end up getting a wound in the air limo. Oh, is it a bit loud? Because I can turn down the volume of the microphone. Let's see here. Okay, let's see. So is this any better? That's me talking kind of loud. This is me talking normally. Oh, you ended up getting a wound in your left ear from using the earbuds. Wow, that... How? That's why I use these boys that are over ear. So is the microphone too quiet now? Like it looks perfectly fine on the in the mixer. So it's probably gonna take a while for me to get all of this right, all of the settings and whatnot. It's fine for me. Good. But yeah, I'm actually gonna be... Oh, sorry. What's up, man? But yeah, I'm also gonna be streaming some tonight. Because I'm just having a lot of fun working on Jolt and streaming and stuff like that. And I once again forgot to save. Let's just make sure... Okay, it doesn't crash. Good. Let's go ahead and save that. And they don't collide with each other. And I can speak very good English. Let's make it so they collide with themselves, but not with default. And that looks to be the case. Good. Awesome. And sphere and capsule colliders seem to work just fine. Okay. So I'm gonna go ahead and push this, and then I'm gonna write some, like, a little to-do list. Let's see here. Added more colliders plus layer support. Added sphere collider support for Jolt and physics. Capsule collider support for Jolt and physics. Added layer support for Jolt. Changed capsule collider component height to be half height. Cool. So that's what I did. And let's bring up Notion. Just write up a quick little sort of to-do list. So I need to rework rigid body API. I need to better handle broad face layers. Handle broad face layers better. Currently very inefficient. Because like, yeah, the thing is, the way we add shapes in Jolt is literally when we construct the rigid body, because that's what Jolt expects. But in the physics system, we attach them like this, right? We don't create them in the constructor. We kind of do like this. I'm probably gonna change that to work more similarly to how Jolt handles things, because I think it's a lot better and a lot more efficient. So we need to do that. What else do we need to do? If we take a look in the physics test scene. Mark a redeemed hydrate. All right. Well, give me a moment while I go and fetch my water bottle. You wanted something to drink as well, so well, I had a Monster, but I drank it. Should buy a new one. I'm going to the store today either way, so. Okay. Thank you for that markup. So, pretty much all of these are working, except for the trigger. The trigger does not work right now. Where is it even? Well, it's somewhere. I had like 6 monsters over the past week, so now you're drinking cola. I should make the chat on stream have like a bit of a darker background, because it's difficult to read the names and messages sometimes. So yeah, we need trigger support. Add trigger shape support to Jolt. That's one thing we need. We obviously need to deal with the entire C# API. Mesh colliders. Add mesh collider support to Jolt. But that's kind of like, I'm not going to be doing that for a while. We need to finalize the shape API. Finalize shape API. Currently very bare bones. I'm probably gonna rework the rigid body API next stream, which I'm gonna be streaming tonight at around probably like 6 p.m. my time. I'll schedule it on Twitch so you guys can check what that is in your local time. Marco already knows because it's the same. So yeah, I'm probably gonna do this next. Rework the Rigidbody API. Then add trigger shape support. And then finalize the shape API. Then probably mesh colliders. Well, no, probably not, because that's going to be a pain to implement. It's going to take a while. But like next stream, I think I can get through the rigid body API, trigger shapes, and getting the shape API much better. So this is kind of like the very basic to-do list. So yeah. Cool. Well, I'm going to go ahead and end the stream here. I'll make sure to schedule the next one. So you should be able to see it pop up in about like 5 minutes. So yeah. Cool. Thank you all for watching. I hope you enjoyed the stream. And hopefully I'll see you next stream. Bye-bye.